Very good morning, my dear students. So, in this third PPT, I'm going to explain you about the what do you mean by Pascal law and its application. Okay, so almost all hydraulic fluid power system work based on this Pascal law. Okay, so what is the main important of studying this Pascal law is Pascal principle. It is also called as a Pascal law in a fluid, that is maybe a gaseous or liquid. Both are in liquid stage. Okay, so statement, it is the Pascal law statement said that the in a fluid at a rest in closed container, a pressure changes in one point in a one part is transmitted without loss to every portion of a fluid, and the wall of a container is called as a Pascal law. So these are the main simple terms. We can say that we can call as Pascal law. Okay, so normally Pascal law formula is state that is the equation force P is pressure is equal to force by area. Okay, now so why Pascal law is so important in now in liquid fluid. Okay, so let me study this. So here I shown in the picture, just you see the Pascal law. According to this statement, Pascal is the name of the person who invited this statement, hence it is called as hence it is kept his name. Okay, that is Pascal law. Okay, so it is state that the pressure at any point in a body of a fluid is same in every direction, exerting equal force on equal areas. Okay, so and is called as in Pascal, and normally this statement work out for the gases. Okay, gases on liquid, both are in fluid stage. Okay, so it is called as Pascal law. So in the diagram also shown, if that is if you taken in a balloon or something, or on a container, if you put an external force or an external pressure, the all the inside or it on the all the area equal pressure will be distributed, that is okay now. So that is called as in Pascal law. So I will repeat once again here. Pascal law state that the pressure at any point in a body of a fluid is the same in every direction. Okay, exerting equal force on equal areas. So this is called as a Pascal law. Okay, and this workout this definition work with gases and liquid, and that is both are in fluid stages. Okay, next, that is a formula. So if you solve problems, you will understand this. The Pascal law, that is this brings us to a very important formula, that is P is equal to force by area, that is pressure is equal to force divided by unit area. Okay, so pressure, force, area. Okay, P stands for pressure, F stands for force, and A stands for area. Okay, so this expression that pressure is force per unit area is called as Pascal formula. Okay, next one is a different if your fluid flows in a different direction in a hydraulic system, based on that we have generated a formula, that is a variation of Pascal law. Okay, so first formula already stated, that is pressure is equal to force divided by area. Second one is equal to force is equal to pressure times of area, that is force is equal to pressure into area, and area is equal to force by pressure. Okay, based on the given values, given quantity, given data in the given problem, we are going to use this three type formula. Okay, so next one is that is same. Let us consider with an example of an Pascal law. Let me understand this. Okay, so consider a, imagine here I shown in the big diagram. Here it is on container, that is a U shape. Okay, now here one side is a smaller thickness, a smaller area. One side, another side is larger area. Okay, that is first point is called A, and the second one is called as B, that is B point. Okay, so consider the just to imagine the given below diagram, that is a column is filled within water. The ends of each column A and B have been blocked by a piston. Okay, so here just to blocked by piston. Okay, both the side. If piston A is pressed, what do you think will happen to piston B? That is very important. Okay, the piston B is going to rise up. We have just applied Pascal law to our fluid pressure. So what is the Pascal law here? Okay, so here if you apply force here, how much down area will go down inside, that much of area this will go top side of this side. Okay, so here pressure at point A1 is equal to pressure at point B1. So here almost all the area P1 P2. Okay, now so here at point A pressure is P1 is similar or equal to at point pressure B is equal to at point B also pressure P1 only. Okay, so P1 is equal to P2. So okay, now so equal amount of pressure will be distributed in the both the sides. So this according to the definition Pascal law. Okay, next, what do you same according, just to apply this law on that diagram. Okay, according to the Pascal law, the external static pressure applied on a confined liquid is distributed or transmitted evenly throughout the liquid in all the direction. Okay, so here same, if you apply pressure here, the whole amount of liquid equally distributed inside this column. Okay, the static pressure acts at a right angle to any surface in contact with the fluid. Okay, now the Pascal also found that the pressure at point for a static fluid would be same across all the planes passing through that point in the fluid. Okay, Pascal law is also known as Pascal principle. Okay, sometime in examination they may ask you what do you mean by Pascal law or Pascal principle. Both are same. Okay, next one is what are the applications of Pascal law in real life situations. Okay, so Pascal law used almost all the mechanical sector area. Okay na, so here some of the important areas I listed here. So first one is in automobile. Okay, in automobile Pascal law is used, that is almost all the vehicles. Okay, hydraulic brake systems, okay, hydraulic jock, hydraulic press and hydraulic machines, okay, etc. Okay, so in also in mobile sector also they are using in Pascal law applications. Okay, so here some two advantage I listed here. So this is an hydraulic brake system. Okay now, so already it is an anti-lock braking system images here just to see the front wheel components. So how the Pascal is helped in a hydraulic braking system. Okay, that is application, that is in example one. Okay, so here the braking system of a car, bus, etc. take anyone, so four-wheeler component also work on this is work on the Pascal. Okay, now the hydraulic brakes allows the equal pressure to be transmitted through the liquid. Okay, when the brake is pedal is pushed, it exerts a force on the master cylinder, okay, which increases the liquid pressure on it. Okay, the liquid pressure is transmitted equally through the liquid in the metal pipes to all the piston of the four cylinder. Okay, so due to this increase in the liquid pressure, the piston in the cylinder moves outward pressure to the brake pads within brake drums. Okay, the force of the friction between the brake pads and the brake drums stop the vehicle. Okay, here see the this hydraulic braking system, that is a power braking system in anti-lock braking system, almost buses, cars that work on the principle of Pascal. Okay, when you apply a sudden when if you press a pedal, that is a brake system, the liquid if you press a pedal, then there is an equal pressure distribution takes place. Okay na, so the force is exerted on a master cylinder. Okay, so from the master cylinder equal amount of liquid flows all near all the four. Okay, with the help of some mechanism. Okay, so that is the brake pedal mechanism. Equal liquid flows and the normal at the finally the all the four wheel can be stopped suddenly. Okay, so this is one example for the Pascal law. Okay, second example is hydraulic lift. Okay, so in a hydraulic lift also we are using the Pascal application only. In a hydraulic lift, a narrow cylinder A is connected within a wider cylinder B. Just to assume this A and B, there are two sides and they are fitted within almost a right airtight full tight piston. Okay, so in field the some in it is a field with some incompressible fluid. Okay, pressure can be applied to move the piston in the cylinder A in the downward direction. Okay, the pressure so applied is transmitted according to the Pascal principle the piston of the cylinder B. Okay, consequently the piston B moves upward in a hydraulic lift. The piston B is used in a platform for a car or any heavier object to lift it like a truck, car, also in a playland. So here I forgot to bring put here diagram. Okay, so take any hydraulic lifter also, if both the sides are A and B, both are fitted within a incompressible fluid. Okay na, when you apply a pressure on that A side, that is a A1, then the hydraulic lifter, that is a piston of the cylinder A is become the direction become downward. Okay, so due to this it transmitted due to this a pressure is transmitted according to all the direction equally. Okay, so this is according to based on the Pascal law principle. Okay, so here I forgot to put here one diagram so that you will understand better. Okay, so this is in hydraulic lifter also we are using the Pascal law to lift the hydraulic that is any job, any carry material, the Pascal law is application is needed here also. Okay, to complete the given work. Okay, and next is according some related definition with related to the Pascal law. Okay, so here then what is the mean by alternative to the Pascal law? So alternative title, that is Pascal law. Pascal principle is also called Pascal law in a fluid, or that is gases or liquid. In a mechanics statement they state that in a fluid at a rest in a closed container, a pressure changes in one part is transmitted without loss to every portion of the fluid and to the wall of the container. Okay na, so same. So here that is if you apply one side pressure, then equal amount of pressure is distributed in all the area and also same forces. Okay, that is about an alternative Pascal law. Okay, second is what Pascal law on a fluid power. Okay, so this is nothing but it is a principle in a fluid mechanics given by the Blaise Pascal that state that the pressure changes at any point in a confined incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere. If something changes small at the beginning, then throughout the whole system can change the changes. Okay, that is with the help of incompressible fluid. That is about the Pascal law of the fluid power system. Okay, so what do you mean by Pascal principle? So this is again, this is a repeated definition. So Pascal, I also known as a Pascal principle, said that when an object is immersed in a fluid, it experiences or equal pressure on all the surfaces. Okay, this is just to underline this, if a object is immersed in a fluid, it experiences or equal amount of pressure is distributed almost all the surface area. Okay, so hydraulic lift and hydraulic machines are the example of Pascal law, and already we studied about these two, hydraulic braking system and hydraulic lift. Okay, does Pascal law depends upon the pressure, whether the Pascal law is depend upon the pressure or not. Based on it only, already we know the formula, that is pressure is equal to force by unit area. Okay, so note that the variation with the height does not depend upon any additional pressure. Okay, therefore the Pascal law cannot be interpreted as saying that any change in the pressure applied at a given point of the fluid is transmitted and diminished throughout the fluid. Okay, so normally sometime pressure is required. Okay, now that is normally force is equal to unit by area, so it will be dependent upon the Pascal law. Okay, so this question is asked in the competitive examination. Okay, so I think you understand this Pascal law. Just to remember this, what you mean by Pascal law and what are the application of Pascal law from this PPT. Okay, so applications are used: automobile, hydraulic brake system, hydraulic jock, hydraulic press, and hydraulic machines. And Pascal law is nothing but when if you apply a force at one point, it will be distributed equally in almost all the direction inside the container, so that equally. Okay, so that is about the Pascal law. Okay, there is no any variation. Okay, and it is related to only the fluid pressure, not any solid. Okay, so I hope you understand this. Thank you.